welcome back to you all to the Data Crack, where we break down the data and crack interview together. I am back with a new topic in statistic, that is the shape of a distribution. Today we are going to study about the shape of a distribution, what is skewness, what is kurtosis, and the visualizations tool that we can normally use to see the shape of a distribution. Starting with the shape of a distribution. So what is the shape of a distribution? Well, a shape, as per definition, shape of a distribution describe how the value in the data set are normally spread out and whether the distribution is symmetric, as we know that as symmetric, skewed distribution, or has peaked or and tail that are more or less extreme, means whether there is more outlier or less outlier. All right, understanding distribution help in choosing the right statistic test and interpreting data correctly. So before moving into the shape of a distributions like skewness, kurtosis, and all, first of all let's understand about the symmetric distribution. What is this symmetric distribution exactly means that? Well, symmetric distribution. All right, symmetric distribution. This is normally the bell-shaped distribution. All right, we normally have the bell-shaped curve. We normally have the bell-shaped curve where our most of the value is around the central, and as we move away our value is less, means most of the value is in the central. Here we normally have mean is equal to median, median is equal to mode. Okay, at here we have mean, median, or mode, all are equal. All right, this symmetric distribution is really important because in statistics most of the theory are based on the symmetric distribution. Most of the statistic calculation are based on symmetric distribution. So having the symmetric distribution data is really helpful and important for us for solving any type of a problem in statistic. It is normally the bell-shaped curve where most of the value is around the central, and as we move far away, and here is also one rule that in symmetric distribution we normally have what the first condition is that mean is equal to mode is equal to, and this is the shape of symmetric, mode is equal to median. All right, and here we do have that one empirical rule. Empirical rule means in the first standard deviation, there is 65% of a data, and in the second standard deviation, all right, in the second standard deviation here is 95% of a data, and in the third standard deviation there is 99.4% of a data. Means the data that is far from this third standard deviation, this is normally considered as outlier. All right, now let's move to our, I hope you have understand this in a rough way, but in later on in later class we will understand about the symmetric distribution totally in detail. Okay, so moving toward the skewed distribution. So what is this skewed distribution? Normally well, speaking about the skewed distribution, normally previously we have said that normally this normal distribution, this symmetric distribution is also known as normal distribution. All right, means normal distribution is all about symmetric distribution, means normal distribution is normally symmetric, but when our distribution is not symmetric, means the shape of a distribution is not symmetric. All right, whether the tail of our distribution, sometime the distribution can be heavier tail can be on the right side or on the left side. All right, when the tail is large or on the right side, we normally call it positive skewed distribution, and when on the left side we call it negative skewed distribution. All right. Well, skewness is all about asymmetric of the distribution. When our distribution is not symmetric, when it is asymmetric. Skewness normally measure whether the data is symmetric distributed or titled toward one side. One side, whether it can be from on the positive side or on the negative side. First of all, we can normally use the formula to see whether our distribution is symmetric or not. When from the formula, when we get 0, skewed is 0, then we can say that it is perfectly symmetric. All right, that is normal distribution or the bell curve. But when it is we can normally say it is a positive skewed when tail is on the right side, that is median is greater than mean is greater than median is greater than mode, and negative skewed when tail is on the negative side. All right. uh, Normally you can just see even in the graph, even from the graph you can easily see that when we normally plot our graph and our distribution is something like when you normally plot your graph. All right, when you normally plot your graph, when you normally plot your graph and your distribution seems to look something like this, means it's something look like this. You can see that tail is on pointed on the right side. All right, so you can say it as a right skewed data. But when tail is on the left side, means you have just plotted your data and it just go like this, means on the left side you can say that it is a left skewed data. But if it is a bell shape, if the distribution is bell shape, you can normally call it as a normal distribution or totally symmetric data. Even in the graph you can see that. Well, speaking about symmetric data, here mean is equal to more, median is equal to mode, or and here in positive you can just normally say that our mean is always greater than median. All right. Similarly, negative skewed data, normally mean is less than median. All right. Means in short you can simply understand that skewness is all about the measurement. It is a statistical tool that measure asymmetry of the distribution, whether our data is positively skewed or negatively skewed. Okay. Now let's move toward the kurtosis. Well, speaking about the kurtosis is nothing but it is just simply the measurement of tailness, means how heavy or light the tail is in the distribution. All right. Kurtosis is the fourth statistical moment. Kurtosis is normally kurtosis is fourth statistical moment. Okay. As we know that mean is the fourth statistical moment, standard deviation is the second statistical moment, and skewness is the third statistical moment, and finally kurtosis, fourth statistical moment is our kurtosis. All right. Now, well, speaking about the kurtosis, it is normally used to measure how heavy or flatter the tail is. Normally, when the tail is flatter, when the tail is flatter, it indicates more outlier or extreme value. All right. When the tail is thinner, then it normally represent less outlier or less risky. All right. As you have already understood, kurtosis is all about the measurement of the distribution has either heavy or lighter tail. We normally have three type of a kurtosis: leptokurtis, platokurtis, and mesokurtis. When uh, when we use the formula of kurtosis, and after once we get the value of a kurtosis, then we will just normally subtract it by 3, and when the value means after getting, for example, after applying the formula of kurtosis, we will get some value. Okay, just let's assume 5, and once you subtract this 5 by 3 or whatever the value you got, and when the value is greater than 0, that value is greater than 0, then you can normally say that it is leptokurtis. All right, it is leptokurtis. Leptokurtis normally represent high peak, means happy tail. It normally has the happy tail which indicate the more outlier. Even in the figure you can say that it normally have the happy tail. All right, it normally represent more outlier. All right. Similarly, here we have play kurtosis. When kurtosis is less than 3, when kurtosis is normally less than 3, it is known as flat. It normally have the thicker tail, means it indicates only the fewer outlier, means there is less risks. All right, but when speaking about mesocortis, mesocortis is normally metocortis, normally kurtosis has the value equal to 3. It normally represent the normal peak or the normal distribution. All right, as even in the figure you can see that this is the this green line, this green chart represent the metocortis, which is a normal distribution or Gaussian distribution. All right, I hope you all understand about the kurtosis. In short, in summary, you can just simply say that kurtosis is all about the measurement of tailness, how heavy or flatter the tail is. You just need to understand this much. Whenever the tail is more flatter, when the tail is more flatter, it is more risky and there is the chance of high outlier. But the when tail is thinner, it represents less risks and the possibility of a less outlier. All right, and mesocortis normally represent the normal distribution. All right, now moving toward the visualization tool that we can normally use to see the shape of a distribution. All right, in order to see the shape of a distribution, we can normally use the histogram. Normally our histogram is like this, as you can even see in the figure. All right, you normally can use the it normally show the frequency of a distribution value. It normally help us to see whether our value is symmetric, skewed, or moderate. All right, similarly we can use box plot to visualize the shape of a distribution. Even it normally visualize the value of a median, quartile, interquartile, and even the outlier. Means as you can see this whisker. All right, if the value is here, means after this whisker, this is normally considered as the outlier. Okay, normally box plot is a visual representation of a distribution. It normally represent the lower quartile, the lower quartile, median, q1, q2, and the upper quartile, that is q3. All right, and here we normally have whisker. It is always of 25% and 25%. So Well, speaking about the box plot is nothing but it is normally used to show the distribution of our data. It normally represents the values such as minimum, maximum, first quartile, second quartile, and the third quartile. And the value after this whisker is normally considered as the outlier. Alright. I hope you all understand about the shape of a distribution, what is skewness, what is kurtosis. Yeah, that's it for today. Thank you so much. In the next video, we will learn about the statistical, inferior statistical in detail. What are the technique for sampling? Similarly, um, um, all the techniques of the statistic in detail. Thank you so much.